So I think we can just continue. It's very interesting that suddenly there seemed to be a rush in support of nested Xen. The previous presentation said a more or less prototype for nested Xen. I want to address more the interface questions and what needs to be considered for a more general approach. So again, a short overview. I think I can go through this very quickly. Nested Xen with PVV devices was covered already, and I will concentrate mostly on the possible solutions, and then I think we should have enough time for some questions afterwards. So first, some naming definitions. L0 Xen, I'm naming the Xen running on the bare metal. And I have, of course, L0 DOM0, the normal DOM0, like on every normal Xen installation. L0 DOM-U is every DOM-U on top of L0 Xen. L1 Xen is the Xen hypervisor running as an HVM guest on top of L0 Xen, and L1 Xen is, of course, at the same time L0 DOM-U. And on top of that, I have L1 DOM0 and L1 DOM-U. And in theory, I could have L2 Xen running as a guest of L1 Xen, but okay, that's more of academic interest, I would guess. Today, as already said, L1 DOM0 and L1 DOM-U's can't access any L0 PV devices, as they have no access to event channels presented to L1 Xen, and same for grants. So L1 DOM0 only sees the devices emulated by QEMU in L0 DOM0, so legacy devices, and this is crippling performance more or less, because going to all the QEMU emulation for every L1 I/O is not very good for performance. What, of course, is the main reason why PV devices were invented. So what we want to achieve is L1 DOM0 being able to use PV devices assigned to L1 Xen. And I want to use those PV devices as backing devices for the backends running at level 1. So this was achieved in XenBlanket by special purpose front-end drivers, and what I would like to see is having a more generic approach that I can use only moderately changed front-end drivers of all kinds, so that I don't have to do massive changes to all the front-end drivers I want to use in level 1 DOM0. So what is the needed functionality for that? Of course, I need to access in some way the L0 event channels in L1 DOM0, and maybe even in L1 driver domains if I want to test disaggregated Xen at level 1. Same goes for grant access of L1 DOM0 memory, which I want to grant to L0 DOM0 for doing IOs. And of course, I need some kind of level 0 Xenstore in level 1 DOM0 to be able to connect my front-end drivers to the backend at level 0. Which, by the way, in XenBlanket, I think there has to be some way of accessing Xenstore of level 0, because otherwise the level 1 front-end driver in DOM0 would have no way to know or to communicate to level 0 how to connect to it. So there are multiple solutions thinkable of for the whole problems. Some general considerations we should think about is maybe it would be a good idea to have one pass-through hypercall similar to the already existing multi-call hypercall, but not for acting in the local hypervisor, but for actions to be passed through one level down. Or is the way to go, like in SendBlanket, adding multiple new hypercalls for each purpose, for event channels, for grants, for Xenversion, and so on. I'm a little bit biased to the pass-through hypercall, but maybe I'm alone with that idea. I have no idea. The next thing is, if we want to support level 1 driver domains, there need to be some kind of multiplexing of level 1 guests down to level 0, because some, for example, events need to be delivered to driver domains from level 0 to level 1, not only to DOM 0. We need access to Xenstore in multiple domains at level 1. We need grant operations from level 1 to level 0 in multiple domains. That's not very easy. So where should this multiplexing be happening? Is that done in level 1 DOMs, level 1 Xen in the hypervisor, or at level 0 level, or maybe even kind of pass-through driver in level 1 DOM 0? And do we want to support even deeper nestings, like already asked? So do we want to have level 2, level 3, level 4 hypervisors as well? And of course, those considerations would be reflected somehow in the interfaces from the level X guests to their hypervisors. So looking a little bit more in detail to event channels, there we have multiple options as well. Do we want a direct mapping of level 0 event channels to level 1 event channels? So when level 0 is sending an event to level 1 DOM 0, for example, should all of those events be channeled through one special nested event channel and then split up afterwards? Or should I just assign a level 1 event channel to each level 0 event channel passed through? Do we want to support only 2-level event channels or FIFO event channels or both? If we want to support both, do we want different level 1 domains being able to use different event channel implementations? So let's say level 1 DOM 0 using FIFO event channels and the level 1 driver domain using 2-level event channels? Yeah? I think this is more meant as a base for a design session afterwards. So I just want to present all the alternatives I'm seeing, and now we should narrow down in more in smaller circles and who's really interested in participating there. Or the other alternative would be like PVShim, that everything goes to L1 DOM 0 and again redirecting from there to the other L1 driver domain. So kind of multiplexing driver in level 1 DOM 0. Grant pages is a rather complicated topic when we would want to support driver domains. If only level 1 DOM 0 is allowed to grant pages to level 0, that's not very complicated. It's just kind of passed through. But if we want multiple level 1 domains to be able to access PV devices of level 0, This is a little bit complicated because today granting works by just the granting domain writing the grant into its shared memory page, interpreted by the hypervisor of the same level. And when we use multiple domains using such frames and passing down the grants one level deeper, there's a problem that the level 0 hypervisor won't have any idea which of the level 1 domains is granting a page. So I have a security problem here at level 1, because the level 1 driver domain could easily just write a DOM0 grant entry into its grant table, and at level 0 this wouldn't be distinguishable from a normal level 1 DOM0 grant. So a driver domain at level 1 could steal DOM0 grants and vice versa. So what would we want to do with the grant frames? Again, multiple grant frame arrays presented to level 0 Xen would be rather complicated, because somehow it's not possible today to say, well, I want to map grant pages of domain X, subdomain Y. So how to, and I don't think we want to change the interface of mapping in the backends at level 0. And the next question would be, if we want to support nested Xen and accessing PV drivers, we should consider support of PVH or HVM level 1 DOM0 or driver domains. So with PV guests at level 1, it's rather easy because they use guest MFN, so level 1 MFNs more or less, when granting a page, but a level 1 PVH domain will use its own guest frame number, and at level 0, the information how to translate that to a level 0 frame number isn't known, so that's not very easy to do. The next topic is Xenstore. In level 1 DOM0, I would need to see 2 Xenstores, one local Xenstore. Level 1 DOM0 would use the backend information in the Xenstore and the front end, local front end information to connect the backends to the front ends. But for accessing the level 0 PV devices, it would need the Xenstore from level 0, the front end entries. And again, for driver domains, how do I forward one Xenstore of one domain to multiple subdomains? So again, the multiplexing question, at which level is it done? Or maybe do I even want to do a kind of mount of a sub-Xenstore? Might be possible. I don't know if it's feasible, if it's a good idea, but I think it should be discussed. So there's a lot of questions, and I think first what's needed is, what do we want to support? How should the interfaces be set up for the far future? What should be possible with those interfaces? Do we want to limit ourselves to a subset of the possible solutions and set up the interfaces for those? Or do we want to architect the interfaces in a way that all theoretically possible solutions will be covered by them? Of course, that would be more complicated in the end. Related work to all this is, of course, the already existing nested VMX SVM support, which was done several years ago, and I think it has bit-rotten a little bit. I'm not sure how usable it is. Andrew isn't here because I think he would have to say some words about it. More recent PVShim is a kind of special purpose implementation of the whole problem with just a single domain at level 1. That's much more easy, of course. Xenblanket we've seen just before my talk. It's a nice proof of concept, I think, but for a general approach, I'm not sure if you want to go with this route. And there's been recently a post of a patch series by Oracle, Anko Aurora, who suggested some changes to the backends to be able to use the normal Xen backends in a KVM host to support Xen HVM guests in KVM. So Xen HVM guest running as KVM guest using the Xen front ends and then running the Xen backends on KVM host. Modified backends, of course. So originally he wanted to have conditional calls in the backends, whether he was running on top of Xen or top of KVM. I talked him into reworking his series, doing a more abstract approach, so introducing a kind of Xen host pointer to each call in the backends for being able to differentiate between the underlying implementation, and this will make it much easier to support nested Xen as well, because then just the underlying abstraction layer could decide whether to talk directly to the hypervisor to use a pass-through hypercall or to talk to KVM host. And that's basically it for this talk. As I said, I wanted to suggest design sessions where we at least should come to a conclusion what to support, the scope of the interfaces, and for the first implementation, maybe the scope where the multiplexing is better be done at which level. So more the general lines of for the first prototypes. Okay, that's it. So the mic is here. He was first.
Just a small comment on the related work list. There's also MicroZen, the sort of type 2 Bromium hypervisor, which I think today runs on Xen server as well and is open source.
Mm-hmm. Okay, thanks.
My question is, probably I didn't understand it correctly, but we are talking about PV drivers, and when we have nested Xen, we implement PV drivers, and you're talking about driver domains. What is the use case for driver domains when we run nested Xen?
Probably yes.
So if we pass through a real hardware device to this L1 Xen, and you want to run a driver domain which will manage this device, or what is the use case for driver domains?
Driver domains, I could think of just testing, having a test bed for disaggregated Xen in an AWS cloud instance, for example.
You can also collect a depth, all of the different filtering, IP tables, and things like that. That's complication that could potentially have us. So running it, I mean, so one argument for running a nested driver
Okay, but what is the relation? Okay, for me, driver domain means that we have some hardware passed into that domain, and it is run by.
It's a device, and so the device available for that system. So in this case, the L0 PV device is the hardware device that you're passing through to the driver.
So actually, no real hardware device is passed.
I wouldn't say it's not possible, but it is possible.
No, it could be possible.
Yeah.
I'm just trying to understand the use case. Okay, thank you.
So if you're using a real hardware device passing through, then you don't need any PV front end for that device in level 1, accessing the device. So this would be completely isolated problem in L1. I'm talking about accessing a PV device of level 0 in level 1. And that, of course, is not for accessing real hardware in level 1, but only virtual hardware.
You might also want to say is if you have multiple devices, you could have multiple PV block devices. You could assign a PV block device directly to one guest. So instead of having to go through the L1, L0, then to the block device, that guest is software in that block. That does mean that the viewers ultimately don't see the
Not necessarily. Not necessarily. If the L1 hypervisor and guest together convey the information about the IOs in a proper way, then L0 is happy with it. It's just doing an IO to L1 or to an L0 guest, more or less. How this IO is multiplexed or demultiplexed by the L1 hypervisor is of no interest for L0. It's just event channel and memory granting, or mapping granted memory, not more. So this is the main purpose of the multiplexing, demultiplexing, grant page support, and whatever I told about, that level 0 Xen, so the backend's running in level 0 and the hypervisor running level 0 should not need to know anything about the level 1 structure. If there are multiple domains or only single domain, it should be of no interest on level 0. That's the goal. So you want to be able to have, as seen in the Xen blanket presentation, take an image, run it on an AWS instance without needing to modify AWS, because that's rather hard to accomplish, I guess, for a normal user, and then being able to use any structure you want at level 1. Okay. Thank you very much.